Hi, welcome to the fifth ISIC skin image analysis workshop at CVPR 2020. My name is Emre Çelebi. Our workshop is not about skin cancer, especially it's about skin image analysis. However, historically most of our submissions come from the skin cancer domain. So talk more about skin cancer image analysis and an important subfield of skin cancer image analysis, which is dermoscopy image analysis. Then I will talk about the growth in these two fields, data sets that fuel this growth, journal special issues that accelerate this growth, and challenges, workshops. Finally conclude with today's workshop. So there are many modalities for skin cancer imaging. The two dominant ones are clinical and dermoscopic images. So on the left we see a clinical image of melanoma. On the right we see the same lesion acquired using a dermoscope. You can see that there are a lot more visible details in the dermoscopic image. You can see the pigment networks, you can see the globules with much more ease. These images are both from EDRA Atlas, which appeared in about 20 years ago. So let's talk about the general field of skin cancer image analysis, which is analyzing skin cancer images regardless of their modality in an automated manner. The first article in this domain was probably Casanelli et al. From 1987. Until mid-90s, most articles in this domain dealt with clinical images. Dermoscopy image analysis has become more popular. The first article was probably Binder et al. From 1994. Nowadays, most of the articles in skin cancer image analysis domain deal with dermoscopic images. So there are many things you can do with a dermoscopic image or a skin cancer image. Most studies deal with one of the following tasks or one or more of the following tasks: segmentation to locate the lesion, extracting features from the lesion, and classifying the lesion based on the extracted features. There are many other tasks you can carry out. You can improve the acquisition step so that the quality of the image is better. You can improve the image after acquisition. For example, improve the color balance, improve the contrast, remove hairs, bubbles, and so on. You can retrieve images based on similarity, and you can detect changes, which is for monitoring the evolution of lesion. This is a bar chart that illustrates the growth of skin cancer image analysis domain based on the number of articles published between 87 and 2019. These are only journal articles, and there's obviously an increasing trend. These red arrows indicate the special issues where the number of, again, publications peak. There is, especially starting with 2016, there has been a renewed interest in this, especially in dermoscopy image analysis subfield, because of various reasons. One is the emergence of deep learning approaches which automate the feature extraction stage, emergence of the ISIC archive data sets, which are much larger than the other older data sets, and availability of higher computational power, especially through GPUs. So let's talk about data sets. The first set of data sets are the historical ones. The EDRA Atlas with about 1,000 images of each type was a very important resource in the early days of dermoscopy image analysis. Menzies Atlas was a little less known than EDRA, but it had also some images, about 200. And the PH2 database had also 200 images, but it had better ground truth compared to some of the other databases of the time. The newer data sets are include the 2016 ISIC data set, which was slightly larger than EDRA, and then the 2017 it doubled nearly, and 2018, 2019, and 2020 the number increased. So we started with about 1,000 training images. Now in 2020, the ISIC challenge data set includes 33,000 training images. That's a massive improvement. So these data sets are very, very important because they have extensive ground truth. They're large enough to permit deep learning tasks. So they are very important for the future of the domain. So one sign of a growing field is the publication of journal special issues. The first special issue is actually quite old, from 1992. It's nearly 30 years old, special issue. The next issue came in 2011, which is 20 years after the first special issue. That is a large period of time. And the latest special issue came in 2019. So another sign of a growing field, and another way to grow an existing field, is organizing challenges and workshops. So as I mentioned earlier, this year we're organizing the 5th ISIC challenge and 5th ISIC workshop. In the earlier years, the challenge and workshop events were simultaneous, and later on we separated them because their focus was quite different. And this year's workshop event, as we all know, is in CVPR, whereas the challenge event will be in MICAI 2020. So here are some statistics on this year's workshop. We received an even larger number of submissions, 43 this year. We were able to accept 10 of them after peer review, which puts the acceptance rate at 23%. Let me talk a little about the program of today's workshop. So we have 4 invited talks. We normally schedule them between 8 and 10 Pacific Daylight Time, but of course now that the event is virtual, we have made the videos of the talks available so that you can watch them anytime you like. We have 10 paper presentations following the invited talks. Again, the videos are available. We have a live event at 12 Pacific Daylight Time, which is the Q&A session. Participants can direct questions to the invited speakers and to the paper presenters. So after this half an hour live event, we will close the workshop at 12:30 with some closing remarks. Again, this is going to be through Zoom. And all the videos, all the papers, slides, they are all available on the workshop website under the schedule. So please be sure to visit this website. We hope that you will find the presentations informative and interesting, and you will get a chance to read the associated papers. And we hope also that you contribute to future ISIC challenges and ISIC workshops. Thank you very much for listening. Have a nice workshop and have a nice CVPR event. Bye.